Hi. Today we'll be going over section 2.1, applications of 2 by 2 systems of linear equations. In the previous video, we talked about the process to set up those two equations when you're looking at mixture problems. In our video today, we'll also talk about how to use a table, and we'll go over problem number 3 and number 4. Let's look at how we can use a table to do what we did in the previous video. When you use a table, you can write out the amount equation and then the value and then the value equation. So you're just writing that extra line so that you can see what to tack on to the value equation. Let's look at problem number 3. 33,000 people attended a ball game at the stadium that offers two kinds of seats, general admission and reserved. The day's receipts were $222,000. How many people paid $13 for reserved seats, and how many paid $4 for general admission? With that information, we can also use a table to plug in the amount equation would be R plus G equals the total amount of tickets, 33,000 physical tickets in hand. The value is how much did each ticket cost and how much did they make. So the reserve seats are $13. The general admission seats are $4. And we know that the total value for the day was $222,000. So when you write your value equation, you just tack this line on here. 13R plus 4G equals 222,000. This table can help you write those two equations. Now let's go through the process of solving. The best way to solve these kinds of equations is to substitute the amount into the value. So you take the R plus G and solve for one of them. So R would equal the 33,000 minus G. Then you plug this into R in the value equation. So 13 times 33,000 minus G plus 4G equals 222,000. Then you can distribute and combine like terms. So 13 times 33,000, 429,000 minus 13G plus 4G equals 222,000. Combine the like terms, so negative 13 plus 4, negative 9G, and then you would subtract the 429,000 to both sides. This would be negative 207,000, and now I can divide by the negative 9. So I see that the general admission tickets would be 23,000. How do I find how many of the reserve seats were made? Well, the great thing about substitution is you can always plug this back into the original amount equation to solve for the other variable. So 33,000 minus 23,000, and you know that the reserve seats would be then 10,000. Okay. Then you state your solution in the context. So 23,000 people paid for general admission seats and 10,000 people paid for reserved seating. Let's take a look at problem number 4. Alexi and Nico used a metal alloy that is 23.5% copper to make jewelry. How many ounces of an alloy that is 22% copper must be mixed with an alloy that is 24% copper to form 88 ounces of the desired alloy? Okay, step 1, let's define those variables. So we'll let X be the physical amount, so the ounces of how many ounces of an alloy that is 22? So the ounces of the 22% copper must be mixed with an alloy that is 24% copper. So the Y will be the ounces of the 24% copper. Okay, so step one, we've defined our variables. Next, we can write our system of equations. So you can write the amount equation, which will be x plus y equals that total physical amount. And they want to have 88 ounces. So x plus y equals 88. You can also plug that here in your table if that's helpful. Then we can create our value equation. What value will you tack on? Notice the x was the 22%, so make sure to make that a decimal. The y was 24%, make that a decimal, and the total is 23.5, so also make that a decimal. And then you can just say 0.22x, 0.24y, and the total is 0.235 times those 88 ounces. So you write your value equation, 0.22x plus 0.24 or 24 hundredths y, and then equals 0.235 times 88. Now that we have the hard part done of setting up the equations, we can solve using substitution. So let's take the amount equation and substitute it into the value. So x will be 88 minus y, and we can take this and plug it in. We'll have 0.22. Instead of x, we'll plug in 88 minus y, and then 0.24y. And let's go ahead and multiply. So 0.235 times 88, that gives you 20.68. Now we combine like terms, so distribute and combine those like terms. So 0.22 times 88, this is 19.36 minus 0.22y plus 0.24y equals 20.68. Combine these like terms and also subtract the 19.36 from both sides. So on the left, you will have 0.02y, and on the right, you have 20.68 minus 19.36, 1.32. Now divide both sides by 0.02 to get that y is 66. The great thing about solving by substitution is once you find one of your variables, you just plug it back in to the original equation. So 88 minus 66, and now I know that x equals 22. And finally, we state our answer with the correct units. So they need 22 ounces of the 22% copper alloy and 66 ounces of the 24% copper alloy. Thank you for working through this with me. I hope you've enjoyed the process. We'll see you next time.